Hello students, in this video,
Question number 15. Find the equation of the curve passing through the point 0, 0 and whose differential equation is y dash. Y dash means dy by dx is equal to e power x sin x. So now we separate the variables. So dy is e power x sin x dx. Now integrate. So integration of this. So integration of dy is y. This is e power x sin x dx. We have to integrate using integration by parts. So remember, isolate. That is, if you have, this is inverse, logarithm, algebra, trigonometry, exponential. You have exponential and trigonometry. So put u as sin x and the remaining, that is e power x dx, take it as dv. It is e power x dx. So it is integration by parts. So one part to take it as u, the other part to take it as dv. Now differentiate here. So du is cos x dx and here you integrate. So v is e power x. So what is integration by parts? U dv is uv minus v du. That means u into v minus v du. That is equal to sin x into e power x minus e power x into cos x dx. Du is cos x dx. Y is equal to sin x into e power x minus e power x into cos x dx. So again you have to integrate using integration by parts. So sin x e power x minus, let us take it as some I or I1. So I1 is equal to integration of e power x cos x dx. So again u is cos x, the remaining is dv. So dv is e power x dx. So differentiate here. Du is minus sin x dx. V is, integrate here. So dv is e power x. So integration by parts is u into v. That is e power x cos x minus already minus is here, so it will become plus e power x sin x dx. This is equal to e power x cos x. This is nothing but your y. We have written this as y. So y is equal to integral of e power x sin x dx. We got the same thing here. Integral of e power x sin x dx. So we can take it as y. So this is now y is equal to sin x e power x minus integral of this e power x cos x, we got it as e power x cos x plus y. So that is y is equal to sin x e power x minus e power x cos x minus y. So you can take the y here. So it will become 2y. So 2y is equal to sin x e power x minus e power x cos x plus the constant c we can put. Now curve is passing through the point 0, 0. So put x is 0 and y is 0. So we can find the constant c. So you will get here, this is 0. Sin 0 is also 0. Yeah, minus e power 0. Cos 0, you know it is 1. So c is equal to 1. So put it back. 2y is equal to sin x e power x, you can take it out. Sin x minus cos x plus 1. Minus 1 e power x into sin x minus cos x. For the differential equation, xy into dy by dx is equal to x plus 2 into y plus 2. So it is given xy dy by dx is equal to x plus 2 into y plus 2. So separate the variables. So we have dy here. So bring all the y terms to this side, left side, and take x terms to the other side. So y dy by y plus 2 is x plus 2 by x into dx. So we have separated the variables. Now you can integrate. So y by y plus 2. How do you integrate this one? See, when the degrees are same, you have y here and y here. Sometimes you'll have x square, x square. Only difference is in the constant. So if the difference is only in the constant, you can always add and subtract. Okay. So just recall or revise your integration also. So remember, when you have the same degree, either or you divide and separate them. You can divide y by y plus 2, normal division, y divided by y plus 2, and then do it. Or you add, the constant is only plus 2. So we can always add and subtract. So add plus 2 minus 2 by y plus 2. So we can separate and easily integrate this. So this will become, this you can easily do it. X by x is 1 plus 2 by x dx. So now here separate them. Y plus 2 group as one term. So y plus 2 by y plus 2 will give you 1, that is dy, minus this 2 divided by y plus 2 is integral of dx plus 2 into integral of 1 by x. So dy is y minus 2 log y plus 2, here integral of x plus 2 log x plus the constant c. This is a general solution. Curve is passing through 1 minus 1. So put x is 1 and y is minus 1. So we will get the particular solution. So put y is minus 1. We will get minus 1 minus 2 log y plus 1, that is minus 1 plus 2 is 1. 1 plus 2 log 1 plus c. So log 1 it is 0. Log 1 value is equal to 0. So this will become minus 1. This is 0 is 1. This is also 0. So what is c equal to? Minus 2. So that's the answer. Y minus 2 log y plus 2 is x plus 2 log x minus 2. We can simplify this, take all log terms to one side. Y minus x plus 2 is 2 log x plus 2 log y plus 2. This is log, power rule, apply the power rule, it will become x square plus log, when you put x square you need not put the modulus sign, y plus 2 the whole square. So that is equal to log, you can use the product rule here, plus sign. So x square into y plus 2 the whole square. So the final answer is y minus x plus 2 is equal to log x square into y plus 2 the whole square. Find the equation of the curve passing through the point 0 minus 2. So the curve is passing through the point 0 minus 2, given that at any point on the curve, product of the slope The slope of its tangent is nothing but dy by dx. Slope of the tangent in terms of differentiation, that is derivatives, slope is nothing but dy by dx. You have learned this last year. So slope of the tangent means dy by dx. The product of the slope of the tangent and the y coordinate of the point is equal to the x coordinate. So you have to form the equation now. The product of the slope, that means dy by dx, the product of the slope and y coordinate. So that means into y is equal to the x coordinate of the point. That's what is given. So now you separate the variables. Dy is here. So keep y terms here and x term to the other side. So y dy is x dx. Now integrate. So y square by 2 is equal to x square by 2 plus the constant c. Now it is passing through 0 and minus 2. So put x is 0 and y is minus 2. So 2 square is 4, 4 by 2 is 2, c is 2. So we get y square by 2 is x square by 2 plus 2. So that's the answer. And simplify this. So y square minus x square is 4. At any point of a curve, the slope of the tangent, so slope of the tangent means dy by dx, is twice the slope of the line segment joining the point of contact to the point minus 4 minus 3. So this point, this is the point on the curve. So this point and this point slope we have to find. So it is given the slope of the tangent, that means dy by dx is twice the slope of these 2 points, the slope between xy and minus 4 minus 3. Minus 4 minus 3 is a point somewhere else. So that slope you have to find. So there is a curve and you have a point and the slope at that point. The slope at that point is dy by dx. Now there is a point minus 4 and minus 3. Okay, minus 4 minus 3. So this slope, how do you find this slope? What is the formula to find this slope? y2 minus y1, 2-point form, x2 minus x1, y2 minus y1 by x2 minus x1. So minus 3 minus y, or we'll take it like this, y plus 3 by x plus 4, y2 minus y1 by x2 minus x1. So that is equal to twice y plus 3 by x plus 4. So this is the equation we formed. Now you have to find the curve, equation of the curve. So let us separate the variables. You have dy here. So bring y term to this side. So y plus 3, dy by y plus 3 is 2 times dx by x plus 4. So now integrate. So this is log y plus 3 is 2 times log x plus 4 plus, when you have log everywhere, you can put the constant also as log c instead of c, and later changing to e, you can always put it as c itself. So this is log y plus 3. This is equal to this power rule, apply the power rule. So log x plus 4 the whole square, the 2 goes here, plus log c. Now use the product rule here. So log y plus 3 is log x plus 4 the whole square into c. So now remove log from both the sides. You get y plus 3 is x plus 4 the whole square into the constant c. When you remove the log, you need not put the modulus sign. Okay, now the curve is passing through minus 2 comma 1. X is minus 2, y is 1. The curve is passing through minus 2 and 1. So put y is 1, it become 4. Minus 2 plus 4, 2 square is 4. So C is 1. So the final answer is y plus 3 is x plus 4 the whole square. C is 1. Question number 19. The volume of a spherical balloon being inflated. So the volume is increasing, it is changing at a constant rate. So in differentiation, whenever they say something is changing with respect to time, use differentiation. Use the concept of differentiation whenever they say something is changing with respect to time. Okay. Rate of change of volume is denoted by dV by dt. dV by dt is a constant. That is the first line. The volume of a spherical balloon is changing at a constant rate. Now, if its radius is 3, initially means write the timeline, that is when t is 0. When t is 0, the radius is 3. After 3 seconds, that is when t is 3, the radius is 6. Find the radius of the balloon at time t, that is when the time is t, what is the radius? The answer will be in terms of t itself. So that is the question. T is 0. So we use these values, that is t is 0, r is 3, t is 3, r is 6. These to find the constants. There will be constants in this. There will be two constants actually, because already one constant is there, k. And when you integrate, you will get another constant. There will be two constants. To find the two constants, they have given two values here. Okay. So let us write now. dV by dt is equal to k. Now separate the variables. So dV is k dt. Now integrate. E is kt plus c. It is a spherical balloon. The volume is, so let us take r as the radius. So it is 4 by 3 pi r cube. So 4 by 3 pi r cube is kt plus c. So we have two constants. Let us use t is 0, r is 3. We get one constant. So when we put r is 3, you will get 4 by 3 pi r cube. T is 0 plus c. So that is, what is that will get you now? 36, isn't it? 36 pi is c. So this is that equation. So we found a constant, put it back in that equation. So volume is 4 by 3 pi r cube is k into t plus the constant c. The constant c is 36 pi. Now there is another constant k. Let us use the second condition. T is 3, r is 6. R is equal to 6. So 4 by 3 pi r cube is equal to k is t is 3. So it will become 3k plus 36 pi. So what do you get now? 36 into 8 pi minus 36 pi, isn't it? Let us keep the 36 as it is equal to 3k. We want to find k. So we can take out the 36 pi. That's why I kept 36 as it is. 8 minus 1. 8 here minus 1. That is 7. So can you cancel here? 12. So 84 pi is the constant k. So we found the constant k also. Now put this here. This is the second equation. So already we found c. So the final equation is 4 by 3 pi r cube is equal to k. We found it is 84 pi. K is 84 pi into t plus 36 pi. Cancel that pi every 9. So r cube by 3 is 21t plus 9. So radius is asked, right? So r cube is equal to 63. So r is equal to the whole power 1 by 3. The next one, in a bank, the principal increases continuously at the rate of r percentage per year. So the principal is increasing at the rate of, that means that it is changing, the principal is changing with respect to time, with respect to, that is year per year. So it is again with respect to time. So let P be the principal. Now dp by dt, that is that it is changing with respect to time. How it is changing? R percentage. So it is R, P is changing, it is R percentage. The rate of change of P is R by 100 of P. It is not just R by 100, isn't it? It is R by 100 of the principal. So it is R by 100 of P. It is not just R by 100. So it is R by 100 of P. Separate the variables. So dP by P, R by 100 dt. R is a constant, so rate is not changing. So log P is R by 100 into T plus C. So now we have to find the constant. If you find the constant, what is given here? Find the value of R. If the rupees 100 double itself in 10 years. So initially, that is when T is 0, P is 100. Initial amount is 100. Now when T is 10, it becomes double, that is P is 200. The question is find the value of R. So what is the rate? Find the value of R if rupees 100 double itself in 10 years. Put T is 0. So log 100, P is 100. R by 100, T is 0. Plus C. That means C is log 100. This is now the equation will become log P is R by 100 into T plus log 100, because your constant C is 100. Next is T is 10. Put T is 10. P is 200. So put T is 10 and this will become log 200. Okay. P is 200, R by 100 and T is 10. Log 100. So log 200 minus log 100 is R by 10. Quotient rule, okay? Log A minus log B is log A by B is R by 10. So log 2 is R by 10. I think log 2 value base E is given as 0.6931. Log 2 value is given in the question. So you can just put it here, 6931 into 10 is R. So R is 6.93%.